Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to talk about the product rule of differentiation. Let's start. If a function y is defined as f of x times g of x, that's a product, okay? I've denoted product by that dot, okay? fx times gx, then its derivative according to the product rule. The product rule says that the derivative of this function, if it's given as a product, is given by y prime is f prime x multiplied by g of x plus g prime of x times f of x. So that's a nice combination there, okay? So you are differentiating both of those individual functions, but the way when you write down the derivative, it's f prime x, the derivative of the first function multiplied by the second function as it is, okay? So gx, f prime x times gx, okay? That's times, plus g prime x, the derivative of the second function multiplied by the first function as it is. There's another variant of this formula or the product rule where you can identify the product rule like this. If y is given as u times v, again, u and v represent fx and gx. Okay, it's just a compact form of recognizing or remembering this product rule. If y is u times v, then the derivative y prime can be written as u prime times v plus a v prime times u. So this might just be easier to remember, but it's not just about remembering the rules. It's about using them correctly, when to use the product rule and how to use the product rule. That's more important. At the same time, I must say that all these rules, whether it's a product rule, we are going to talk about the quotient rule, the chain rule, the different rules, the formula for differentiation, they are all generated from the limit of the difference quotient. That derivatives by first principle, differentiation by first principle, they're all derived from there, okay? So we need to be really, really grateful and thankful that we've got these compact forms of remembering the formula. But the most important thing is, how do we use them, okay? So that's what we're going to take a look at today. Example 1 will be y is equal to x plus 1 times x cubed minus 1. This is a very simple example. We'll take another example after that. This is just to illustrate how to use the product rule, okay? First, learn how to use the rule, and then we can take on some more, challenging examples. This question could have been solved by multiplying the two brackets and then performing differentiation term by term. But let's try and see how you can use a product rule to solve a question something like this. What we're going to do is that we're going to identify each of these terms as u and v. It's a product of two terms, right? And we're trying to use the product rule. So first we'll do is we are going to write down u as x plus 1 and v as x cubed minus 1. And then we're going to find out the derivative of each of those u and v. So u prime is going to be the derivative of x plus 1. The derivative of x is 1. The derivative of 1 is 0. So u prime is just 1. V prime, the derivative of x cubed minus 1. Well, the derivative of x cubed is 3x squared. The derivative of a minus 1 is going to be 0. So the derivative of v prime is just 3x squared. Now that's not over. We need to put these things together in the product rule form, okay? So when we do that, we get for y, we get the y prime, the corresponding y prime will be u prime times v. U prime was 1 times v is x cubed minus 1 plus v prime, which is 3x squared, times u, which is x plus 1. Okay, so be careful how you're using the product rule. It's u prime was 1, u prime times v plus v prime, which is 3x squared, times x plus 1. And then we simplify it to get x cubed minus 1 plus a 3x cubed plus 3x squared, and that is basically 4x cubed plus a 3x squared minus 1. And that is the derivative of this original function x plus 1 times x cubed minus 1 using the product rule. Let's take another example. We'll take this one, e to the x times 2x cubed plus 4x. Okay, so this is our example 2. And here we've got y as e to the x times, what was that? 2x cubed plus a 4x. That's it, 4x, okay? Now, sometimes we need to write down these things very detailed, differentiating both sides with respect to x. depending upon what your teacher requires, I can ignore that because I know that the question is asking for the derivatives. So unless until it's a question on applications, where you are supposed to use the idea of the derivative, then you need to indicate what you're doing. But if your teacher requires that you have to write this thing down, make sure you write it down. These examples are just to illustrate the product rule of differentiation. That is why in the first case I did not write the sentence. But if it's an application or if your teacher requires that you write down no matter what, then make sure you write it down. Okay. So here again we identify what's going to be u and what's going to be v. All right. U's are e to the x. U is e to the power of x, and v is going to be equal to 2x cubed plus 4x. Once you've identified them, differentiate them separately. So if you use e to the x, the derivative of e to the x is e to the x. Know all your rules, okay? Those things you need to commit to memory. And then v prime would be equal to the derivative of 2 times x cubed. There's a constant multiple, so you can say 2 times 3x squared plus a 4, okay? Because that's again a constant multiple, 4 times the derivative of x. So 4 times the derivative of x is just like saying 1 times x to the power of 1 minus 1. Okay, I just did it in one step. There you go. So when you simplify that, you'll get v prime as this is 6x squared, and this is going to be just 4. 1 minus 1 is 0, x to the power of 0 is 1. So then we have to put it together to find the derivative of y. We can say dy by dx, this time we're using another notation. That's okay, it's still the derivative, is going to be equal to u prime times v. So it's e to the power of x times 2x cubed plus 4x, that's u prime times v, plus a v prime, which is 6x squared plus 4 times a u, which is a e to the x. Now you can open the brackets and simplify that to get, you'll get 2x cubed times e to the x plus 4x times e to the x plus 6x squared, 6x squared e to the x plus a 4 e to the x. Actually, you can bring that e to the x as a common term outside. Simplify it further by factoring out 2 times e to the x from each term to get, this will be x cubed, and this will be 2x, and this will be a 3x squared, and that's going to be a 2. So your dy by dx, the derivative, is going to be that entire term, and that term basically came from using the product rule on this original function e to the x times 2x cubed plus 4x. Okay, so what do? We just identify u and v separately and find their derivative separately, and then use the formula correctly. Okay, knowing the formula is not good enough. You need to know how to use the formula. It's u prime times v plus v prime times u. And then there's a lot of algebra involved. So my tip would be, know your algebra well. Your algebra skills need to be strong, and you need to know all the rules of differentiation. I'm going to see you all in the next video.